Hello friends, today I am going to tell you how to make the SOS light emergency project. In this project, you can see that this is an LED bulb and the light is blinking in the pattern of an SOS emergency light. So the light is first on and then it's switching off, on and off. So this is how. So let's start. So the things required for this project are 2 male-to-male wires, an LED bulb, red color preferably, 1K ohm resistor, a breadboard, Arduino Mega and the Arduino's USB cable. So let's start. So we first start by attaching the LED to the breadboard. First, let's understand that the bulb has two terminals, one positive, one negative. So we can identify it by seeing the longer leg of the bulb. So the leg to the left side, to my left side, is the longer one. So it is the positive terminal, and the other one, which is the shorter leg, is negative. So there are also negative can also be said as cathode and positive can be said as anode. So keep in mind where you are placing your positive and negative legs. So here on the breadboards you can see small holes in here. So our legs will go in these holes. So I attach it to the breadboard. One leg goes in one hole and the other leg goes in the other hole. And one very important thing to remember. So what happens is, in the breadboard, what happens is that the connections, they're vertical, like this left side is my negative leg. So here, instead of putting so if we didn't have the breadboard, what we would do is tie the negative terminal of the bulb around this male-to-male wires leg. But to avoid all that difficulties, we use the breadboard. Here we place the breadboard, and instead of fusing the wire with the leg, what we can do is place the wire vertically below the bulb. So for example, if the left side is my negative leg and this is the negative wire, so what I will do is place a wire below it. Place the wire below the negative leg, just below the negative leg. Either I can place it in this hole, this hole, this hole, or this hole. I can't place it here because there is a break in between the breadboard. So this is called a break. So here and here, these both are not connected, these both sides. So what I can do is place the wire vertically below the negative leg. I can place it either here, here, or here. So I'm gonna place it anywhere. For example, suppose I place it here. Now the other end of the male-to-male wire, we place it in the Arduino. In the Arduino, a negative terminal is always connected to the GND of the Arduino. Here you can see GND. So there are 5 GND terminals or ground terminals in Arduino Mega. If you have another module of Arduino, then it might be different. It depends on each Arduino module. This is Mega. So in Mega, 1 is near the AREF tag, here below it, ground, this one. We have 2 here in the power side and 2 here in the digital side. So we can use any one of them if you like preferably anywhere. So I'm just going to place it anywhere, but a ground terminal. So this is our ground terminal. So here we go. We have attached the first wire of our LED. So this goes in ground. It can either go here, there, or anywhere here. Now we attach the second wire. So the second wire goes to the positive terminal of the LED. So first what we do is attach this 1 kilo ohm resistor. So the job of a resistor is to resist too much energy from going into a thing. So for example, here the Arduino provides some watts of energy, say 3 watts or 5 watts. So but the LED also has a certain capacity to hold some amount of watts electricity. So if you flow in too much of electricity into the LED will burst. So in order to prevent that, we use resistors, and preferably we will use 1k ohm resistors. They are the most highly recommended resistors for LED works and all. So here is the negative leg of our LED, and now we can attach it vertically anywhere in between these 4 holes. So I'll just place it here, one leg. You can place the resistor. The resistor doesn't have positive or negative terminal. You can place it anywhere, like to the positive terminal or the negative terminal. Next, we put the next leg of the resistor to another hole, which is horizontally, next to the first leg. So like this. So I have placed the 2 legs. Now, if we see this, our circuit is flowing like this from the resistor. From the leg we start, it goes from here to the first leg, and then it goes here, and then it comes here. Now we need a wire to connect it. Now as I told you, there are vertical connections in the breadboard. So I connect it vertically. From here I can place it anywhere between these 3 holes. I place it here. Now this is done. We need to connect this second end of the male-to-male wire to the Arduino. So you can connect it. You have to connect it in this right side part, the communication part here, this digital part. You have to connect it anywhere. So you can connect it from pin number 2 to pin number 13 to pin number 12, sorry. So why we don't use 0, 1 and 13? Because 0, it is the receiver terminal. It is used for other sensors such as ultrasonic sensor or so. And the TXO is the transmitter. It is also used for ultrasonic sensors or so. So this is the transmitter part, this is the receiver part. Here 13 is a specifically designed, you can use it, but the code I am showing in this, what I am making is different from what we code in the 13th pin number. It's specifically designed for some users, Now here I am going to connect it to pin number 2. You can connect it anywhere, but I am connecting to pin number 2 because pin number 2 is in my code. I'll tell you how to change the pin numbers in the code in the coding part, but now let's do this part. So here we attach it to pin number 2. So yes, our hardware connection is done, and don't forget to attach the USB cable of the Arduino. So this part, as you can see, goes to the silver part of the Arduino. We attach it here, and then this USB port, we attach it to a laptop so that you can do the coding part, or any device, So now this, I have connected it to my laptop. Now you can see the LED is glowing. It's flowing in the SOS pattern, but you won't have it because you need to do the coding part first. So now I will show you the coding part. So guys, this is the app that we are going to use. So the app's name is Arduino Genuino. I will attach the link for the app in the description. So here is the code. I will attach the code also along with the link in the description. So let me just quickly summarize the whole code. So this is the comment bar. So this is used to comment something which is not important in the code. So this is not important. Void setup. This is the setup of the code. This is pinMode to output. So our pin, the positive pin we attach the bulb with is pin 2, and it is the output. So this is what we put. Now, as I told you, to change the, to change the pin, we can, just click here, edit it to 4, 5, or anything, 4, 5, 6, 7, something like that, between 2 to 12. And then you would have to change it here also. Now this is void loop. This is the loop. If you have done block coding, this would be easier for you. The loop which is there, you put some codes, so you don't have to put it again and again. So loop means it will keep happening until you switch off the thing. So this is digitalWrite too low. So this is the format of the code. So we write digitalWrite first and then too low. This means pinMode 2, it shouldn't give any output. It should be low only. Then delay 1000. It means wait for delay by 1000 milliseconds, that is 1 second if you see in seconds. DigitalWrite to high. It means now the bulb will be switched on. Then delay for 2 seconds. And then digitalWrite to low, and then bracket close. So this is only the coding part. Only this much is required. Now connect your Arduino's USB port to your laptop's USB port. Now check all the things. Go to tools and then see the board should be Arduino Mega or Mega 2560. So this is if you have Arduino Mega board processor, add Mega 2560 or Mega 2560, port COM5 Arduino Mega or Mega 2560. So these all should be your settings. I'll just show you again just so that you can do it. Yeah. So now we go to the uploading part. We upload it to our project. So first we verify it. If our code is correct, it will first compile the code. We'll see if there are any errors in the project. So nothing. Now we go on and upload. And remember to save the file. So now our code is uploaded and now our project will work. So now let's go to the saving part, how to save it. This, you have the last option in this bar, save. You save here and then it goes to your desktop and then browse and then you save it wherever you want. So thank you guys. Meet you in the next video.